Hi, this is Michael from Expanse VR, and in this week's first-person shooter episode, I'm going to be showing you how to use mouse look so that we can start looking around with our player and also apply gravity. And finally, I'm also going to show you a nifty little trick how to get around a small little obstacle we're going to come up against when we're moving around with our player. And if you're new to the channel, don't forget to like this video, subscribe to the channel, and of course click that notification button down below to make sure you are notified whenever I post a new tutorial for you. And before we get diving right into the coding aspect of this, I'm just going to show you something that I've done in the last week. Well, actually, to be honest, I've just done it this afternoon before recording this, and something I'd like to see you start doing yourselves. So all I've done, if we zoom in here, this is the original room that we started with last week. I've just tacked on this little hallway to give us a little bit of extra movement before moving into it. Now, why this is important is because this asset that we've used in here, the snaps level, is got more functionality than just this simple first room. You can add onto it, and it's a great tool for prototyping and getting some ideas. And what we're going to be doing in later episodes is adding functionality to these rooms, like we're going to be able to interact with this little console here, we're going to be able to open and shut doors, and lots of other bits and pieces. But a part of that is also learning how to move around the prefabs that are provided to you. So before we get stuck into the coding, what I'm going to show you here, if we go into the asset store originals, snaps prototyping folder, and sci-fi industrial, because there's some other ones that you can get with the snaps prototyping, and you're going to see in here we've got a bunch of prefabs. And the prefabs in here are what you can use to make your level. And if I just step out here, I'm going to show you the best way to do that just very quickly. So here we've got structure, which has got the doors, floors, and ceilings. Now, if you pull in, say, let's start with a couple of floors. So we've got general floor. Now, if we pull this in here, these are made so that they snap together very easily. Now, we can use the snap tools over here, but we're not going to go into that today. I'm just going to show you the quick and easy way to do it. If you do Control D, you'll duplicate the item you have here, and if you hold the control button down while moving the asset, it snaps it along, so we can do right here to a perfect fit. So as you can see now, they are perfectly aligned. And if you do Control and hold the other one down, and do Control D again, holding the Z axis one, the blue one, and moving it this way to there, all of a sudden we've got 4 in a row here, sitting nicely and tightly together. And then if we want to quickly add in a wall, all we need to do is, let's go with this one here, this will do. The easiest way to do this one is if we go here, and we go up to the corner here and click on the options here and go copy. And the brilliant thing about 2021 is that we can actually copy just position or rotation now, not the whole lot. We're going to copy the position, grab the same one, transform and paste position, and then we're just going to snap it across here to where it fits nice and perfectly. Same thing, Control D, holding the control down, we move it here. And if we hold Shift and together, Control D again to copy, holding Control down still till we get to where we want. And then if you hit the E button, we bring up the rotation gizmo, holding Control again down for another quick trick. We can rotate this around and it snaps to, I think it's 15-degree increments. Yes, until we get 180. Holding the W button again, we just move this across till it's a perfect fit. And now you've got the start of a hallway. So nice and easy there. So I'm just going to go ahead and delete this. But what I'd like to see you do for the next episode is add at least one additional room. You don't have to put it where I did, you can put it somewhere else. But yeah, go ahead and make yourself an additional room or more if you want. But definitely at least get one in there. The more you use these snap functionalities, the quicker and easier it's going to get, and you're going to be able to prototype a level very quickly and easily. Like I said, I think this took me 10 minutes to put this room together. And that was me being slightly unfamiliar where some of these prefabs were and having to go through. Anyway, that's enough of that for the moment. And if you like, I have a Twitter account now. You can add me in on Twitter and share a picture of what you've done with your level. It can be either with a JPEG or with an animated GIF, just so I can see how it looks. And just tag me in it and I will definitely check it out. Okay, so the first thing we need to do is get the input from the mouse in the X and the Y position, and this is very similar to what we've done here. We've got a horizontal and a vertical, but we're going to name this slightly different. So we do float once again. This one we're going to call mouse X, and it's a simple thing where we're going to use the input system again. And once more, it's going to be the get axis, but we're actually going to use the mouse X, and once more with the Y position. So as you can see, we're seeing a very similar setup to what we did before. The difference here is, of course, we want to be able to check what the sensitivity of our mouse is. We want to be able to change that, so we need to add a extra variable up the top here. And we're going to call this one mouse sensitivity. And by the way, if I get some of this spelling wrong, don't blame me. My spelling is atrocious at times. I think most programmers are. And we're going to keep this to, what are we going to keep this to? Say something like, I know it's quite a lot more than the speed, so I'll say 50 for the moment. We'll have to play around with that afterwards. So same thing here, I'm going to do times mouse sensitivity, and we're also going to do time dot delta time once more. And we're going to do the same thing down here. So now we've got our inputs. So the next part that we want to do is down here, it says we need to look and aim based on our mouse input. But in fact, this can actually be broken down a little bit further, and I'm going to show you why. So back here in Unity, if we grab our player and we switch the gizmo over to see our rotations, let's think about what we actually want to do. We have two axes that we want to move on. The X axis, because we want to look up and down. And we also want to rotate around. We want to look around ourselves on the Y axis. So we don't need to do anything with the Z. There's only two axes that we're going to be working with. But in saying that, while we want to rotate around here in the Y axis with our player, we don't want to be having our player move around like this. So what do we actually want to do with this? We actually want to be moving the camera. So where's our main camera here? So we actually want to be rotating the camera up and down to look around, and then the player around. So first of all, we need to make sure that our camera is attached to our player. So when we rotate our player around, the camera will remove, of course, because that's the way we're facing. And then on the X-axis, when we rotate the camera, our player is not going to tilt or anything. It's going to be looking up and down, which is kind of like if you think of our head movement. So in fact, if we go back here to our script, this actually is more. We want to rotate the camera based on the X input from the mouse. Actually, I think that's based on the Y input from memory. We'll double check that in a second. Y input of the mouse. and we want to rotate the player based on the X input of the mouse. Again, we'll double check this so we can actually get rid of that line. The other thing is, if we have a look at our player, when we rotate this, so if we go back to the actual player itself, when we're on the Y, of course we can move around as much as we want. But with the camera, we don't want to be able to look too far. We don't want to be looking behind us, and we don't want to be looking underneath it. So we need to what we call clamp this look so that we don't go too far. And I'd probably say that we want to only be able to look up to about, or within, what do we got there? Yeah, minus, you might be able to look just about straight up, but probably something like about 80, and on the way down, probably no more than about 70 or so, but we can play around with those ones there. So we also want to clamp the camera rotation between, I think we said 80 degrees and minus 70 degrees to give a bit more realism. Okay, so let's tackle the first one, which is our rotation of the camera. So before we calculate how to get there, we need to know what we actually are going to be transforming, and of course it's going to be the camera dot main, and it's going to be its local rotation. Transform dot local rotation. So if you look at transform local rotation, in the description, the very first thing it tells us is that Unity stores rotations as quaternions internally. Now, you don't need to know too much about what a quaternion is. You just need to know how to manipulate them, and the fact that Unity and most 3D programs use quaternions for all rotations. I look at this as the whole light switch methodology, where if you walk into a room and need to turn on the lights, all you need to know is where the switch is and how you need to turn that particular switch on. You don't need to know the physics, you don't need to know the electronics behind the switch, you just need to know that is what you use to turn on lights. And it's the same thing in Unity. You don't need to know how quaternions work. So looking through all this has a great example of how to use it. So the only thing we need to do is check down here is that the transform.local rotation, and that is equal to a quaternion.Euler. And you can see in here that there is 3 components, which is your X, Y, and Z rotation amounts. Now this is different to a vector 3 in that it's not giving you an exact location or an exact rotation. So if we look into our transform over here, so it's not actually transforming this. So if you enter 30 into a quaternion Euler, it's not going to turn this to 0.3. What it's going to do is add 30 degrees to the X axis. So for instance, if this is 60 and you entered 30 into that function, it's going to make it 90. So if we jump back into our code, we know that this needs to be a quaternion dot Euler, and it's going to be a vector 3 amount. So for the moment we'll go 0.0.0. Now there's already a problem with this, and a best practice that you should get into habit of straight away. Camera.main should never be used in the update function or any other function that is being called repeatedly like this. Update is being called every frame, and therefore you're calling camera.main every single frame. And camera.main is just like get component or find object, is an expensive call. So what we want to actually do is cache this. And we've done this already with the character controller, so we do the same thing. Private camera underscore camera. And once again, camera equals camera.main. And you may think this is trivial, but for instance, if we started adding all these get components together, it can slow down your game, especially if you're doing something to mobile, other complicated calculations. And the more these add up, the slower it can make your game. So it's good practice to get into. So it's a good habit to get into straight away. So same thing down here. We're just going to change this to score camera. So now we've got our X and Y inputs. We now know how to transform the camera. And before we actually work out the proper calculations, we're going to do the same thing here. Transform. And this is a lot easier because you can rotate it with this one. And you see same thing here, 0, 0, 0. Because we're going to be clamping the camera rotation and not the player rotation, we do have to handle it slightly differently for each one. With the camera rotation, because we are going to be clamping it, we do need to have a stored value that we work with. So the first thing we're going to be doing, and remembering that with the camera, even though we're taking the Y input from the mouse, we are going to be working with the X rotation. So we're going to create another variable up here, which is going to be a float again. Private, I'm going to call this one X rotation. And we are going to give it a 0 value for their start. Sorry, that should be a float. And this is just my OCD, but I like to have serialized fields and non-serialized fields separated, just so they're easier to read. So down here, when we do our quaternion function, we are going to use the X rotation here in the X portion of it here. So now we just need to change that X rotation value. And the first thing we can do there is quite simply X rotation equals X rotation minus mouse Y. So whatever comes in with the mouse, it's just going to come off the value here and be stored. And before we get to the next step, I'm just going to show you something easier to make this a lot neater if you don't know this one yourself. If we use this, the minus equals, we don't need to have that part in there. So just the same way of doing the other mathematical function, just as quicker and cleaner. And the second part is clamping. And if you have not done clamping before, clamping just takes, let's just go through it and you'll see it. It's actually very self-explanatory once you see it being used. So X rotation is just going to equal, and clamp is a math F function. And you'll see with math F, there's lots of stuff that you'll use as we get further and further into it. Clamp. And if we have a look in here for the quick hint, you can see that it's asking for two float values. The value that you're inputting, and the minimum and maximum that you want to clamp it between. So in our case, we want to do the X rotation again, is the value that we're clamping. And we went, what do we say? You need to do the minimum value first, so minus 70 and 90, no, 80. 80 is what we said. In fact, let's make this variables as well. And I'm going to show you another quick little trick that we can do here. Because these are going to be the same, we're going to do minimum camera view and max camera view. And we can go ahead and also assign the values that we had, which was minus 70F. So again, just a couple of shortcuts that you can use to make your code look a little bit neater, or in my opinion anyway. So we've now got this, it's clamped. This value has been assigned here. So this is going to take the X rotation in. So we've now done it, and we can do a quick test to make sure this is working. Saving it, jumping in, push play. So we can see it's kind of working, but it's very slow. And we've also got another issue where our mouse can go outside our boundaries. So before we continue testing, let's fix that little issue up. And all we need to do is in our start function is lock the cursor. So let's try that again. So just quickly testing it out. And there we go, we're working a little bit slow. So I think if we go to player and change this up quite a bit. Okay, not that much. And we try again. So there we go. Mouse look is quite good at 250 on this sort of setting. You can do it to whatever you want, but as you can see, we're clamped. We can't go too far down or too far up. If you are having a little bit of trouble with the mouse not confining to the play area, I don't know if this is a bug with 221. I didn't notice it in 2019, but I found just resetting does make it work. And to get out of it, you just push escape and that brings your mouse back. Now, all we need to do is rotate our player around based on the Y axis. Now, the easiest way for us to do this is that we know we're going to be doing that based on our mouse X, is that we just need to do a vector3 dot up, and then we just need to times it by our mouse X. And if we do play again, now I personally feel that it's not turning enough on the rotation. So I'm actually going to hard code this in because I want it to be similar. It feels like it's moving up and down a lot faster than it is side to side. So I'm just going to put an arbitrary number in here, see how it goes. Yeah, that looks and feels a lot better now. So one small issue I've noticed, which is an error I made in the previous video, which we just need to correct. If you look in the scene view, as I move forward, so pushing the W key at the moment, I move forward, my player's moving forward, I rotate my camera view around, but when I push the W key, I'm still moving forward in world space, not in the direction that the player is facing. And this is just a small little error. And that's the use of the vector3.right and the vector3.forward here. What I actually need this to do is this actually needs to be the player's transform dot forward. So the actual forward direction of the transform. Vector3 is actually going to give us the forward and right in world space. We want it in local space. And this is a good example of the differences between local and world space. So local is what the player is. Local is the player's forward, and vector3 dot forward is the world forward. So we just need to change these two. and save. And now we are going great, and it feels and looks much better now. Now, before we get into gravity, because at the moment we have no use for gravity, we're on the ground, we don't need to be pulled back down. I'm going to show you the first issue that we're coming up against, and that is here. We can't go up any stairs. So fixing up our little problem about the stairs, not being able to go up the stairs. So there are a couple of different ways that you could do this. You could try to play around with the player controller. You could try to work out a script to detect the stairs and everything. But the simplest option is always going to be the best option, and a lot of what happens in games is smoke and mirrors, and you've got to remember that as long as the player has no idea what's going on and it just works, they don't need to know. So here is a very, very simple trick. What we are going to do, is we're going to create a cube. Reset its position. Let it go. Bring it through. Bring it through. All right. Using the R button, we get the transform gizmo. And we're going to bring this down to something nice and thin. Do our best to kind of line it up there with the stairs. Again, let's get it nice and wide. E for the rotate. I'm going to rotate it so it's roughly where we think it is. Stretch this out. Now, if you notice here, the gizmo, the movement gizmo is in global. If we click this to local, we can now bring this up to here, rotate it a bit more. Rotate it a bit more. Looks just about right. We just need it sitting above there, and then just bring it down. So now if we push play, with our player with our nice new smooth movement controls, we should be able to go there, but we can't. So the last thing we need to do is go to the player character controller, and we just need to up the slope limit slightly. I think to about, we'll try 55 first. There we go. And now I've come up the stairs. And this is where we're going to lead to our issue where we need to have gravity, because if we now walk out here, we've turned into Superman. But before that, of course, we don't have this out here. So what we're going to do with this, and we're going to rename this to Stair Assist. We're also going to create a new empty to keep things nice and assistance. and just on this one here, we're going to get rid of the mesh render. So the box glider is still going to stay there and give us what we need. And we're just going to put this in our assistance. Pop it off so we can't accidentally hit it. Same with our scene lights. And now we've got a nice invisible stair assistant. So now moving on to gravity. So back in our script, we've got two things that we need to do. One, apply gravity to our player. But we don't want to be applying gravity all the time because we don't want to have to do the maths if we don't need to. So we need to detect if player is grounded. And then, if grounded, apply gravity to our player. So the first one is very, very easy to do. Our character controller actually has a nice little function called isGrounded. So what we're going to do is create a new function called player velocity. And we're going to check if character controller dot is grounded, and that will return a true or false. We will simply say player velocity dot y, so the downwards velocity, equals 0. Else, and I just realized I wrote that completely wrong. If not grounded, so this is where we can do it. So if it's not grounded, and we don't want that there either, player velocity dot y will equal and if you're interested, that's actually what gravity is, but it can actually be whatever you want. If you want to be a little bit unrealistic, if you want to have it say on the moon or in space, you can change that gravity to whatever you want, but this is normal Earth gravity, which is 9.18 meters per second. And so now that we've got the amount of gravity, we will apply it to our character controller. Now, the reason why we're doing the plus equals is that gravity is an increasing amount. It's just not it's not a linear amount. It increases as you drop. So this is why we're increasing it as we go over time. And then once we hit the ground, it will drop. It will stop. So let's test this out. So we go up our stairs, we look around, and now once we go past the stairs, we should drop to the ground. So as we work from there, you can see it feels a little bit floaty as we drop down. And there's a really good reason for that. Any physics-based calculations that we do in Unity should not be done in update. It should actually be done in fixed update. So if we switch that over to fixed update, that will fix the floatiness. So that's pretty much it for this week. There's one small thing that we're going to start doing, and it's going to be one of the other challenges. So the first challenge I already gave you for next week is to add at least one other room onto our prototype, if not more. But the second thing is, if we have a look at these update and the fixed update functions, they're starting to look a little bit messy, and we don't want to be having all this piled empty here. So for instance, what we're going to do is refactor these to make it a little bit cleaner. And this is something that you should always be looking to do. So what I mean by that is, for instance, this here, as much as we've got the definitions going on there, if we click on the little tool here, we can actually extract this into its own method. And I'm going to name this method player movement. Now, why is it not liking that? Oh, okay, it's not liking that because we already have this as a class. So what we're going to actually do here is change this to controller. Now, when we change classes like this, you need to also come out here and change your script to reflect the same name. Where's that scripts? And if we go to our player, you're probably going to find, nope. There we go. So it's updated itself there now. And we will need to reload it into Visual Basic. So already this is reading a little bit cleaner. We know in update that we're going to do player movement, and we have the player movement function here. I personally like to have fixed update and update together, so we're going to move this around. But I can already tell you that there's two other, in my opinion anyway, there are already two other functions that we should create from this to make this cleaner. So I'm going to leave that for a challenge for you for next week as well. I want you to clean this code up a little bit further and refactor it so that it is easier to read. And that's it for this week. Next week we will continue on. We are going to start interacting with some of the environment, including the doors and the buttons, and then we'll start looking at weapons. Obviously next week it is Christmas. I will try to get out to this next episode before Christmas Day, so you've got something to do over that break if you've got a little bit of time to yourself. Worst case scenario, it will be the week after. But if not, if you don't see a video from me between now and then, have a Merry Christmas and enjoy your holidays. And thanks for watching. Don't forget to like and share to help grow our beautiful Unity community. And don't forget to hit that subscribe and notification button below to make sure you get to see our next video. See you shortly.